All right, so this is the inference for many means lab, the ANOVA lab. So we're gonna start out the same way that we always start out, by loading our packages. So you need to put in library mosaic, then hit that play button to get them to run. And then we're gonna load in the data like usual. It's just the same data set that I've been using all semester. So we've seen how to do inference for a single mean. We've done inference for a difference of means, and now we're going to do inference on many means, 3 or more means. And we're going to use this procedure called ANOVA. So that's short for analysis of variance. And we're going to be sort of doing a comparison of the variability within a group to the variability between the groups. So when we're doing ANOVA, and that's the stuff in chapter 8.1 of the Lock 5 book, we're only doing hypothesis testing. There's no confidence intervals at this point. We're going to get to some of those later on. And the hypotheses are always the same. So the null hypothesis is mu1 is equal to mu2 is equal to ... out to mu k. And the alternative hypothesis is at least one of the means is different. So for today, we're going to think about the variables marital status and number of hours worked last week. And I want to know if the mean number of hours worked last week is the same for all of the different categories of marital status. So I'd like you to think about making a set of side-by-side box plots to show the relationship between those two variables. And I would encourage you to stop the video here and try and see if you can do it on your own before you go on. All right, I'm gonna do it. So we're gonna do gf underscore boxplot, parentheses, and then we need to think about our variables, and I think it's gonna go in this direction, number underscore of hours worked last week, tilde, marital status, comma, data is equal to GSS. Let's try that. Yeah, so I think that came out the way that we want it to. And we can see that there is some variability in the sort of typical number of hours worked. In particular, widowed looks different to me than the rest of the groups, but we're going to use statistics to tell if it's statistically significantly different. So the first question is, how many groups do we have here? And I'm going to say we have 1, 2, 3, 4, 5, not counting NA. So 5 groups. And then we could rewrite our hypotheses to be more specific, to have mu1 equal mu2 equal mu3 equal mu4 equal mu5, and then at least one is different. Or we could write it out to say mu divorced is equal to mu married, etc. for all of the different groups. And now we're going to do ANOVA using R. We're going to use this built-in function AOV, and that's going to find the p-value relating to an F distribution. So it's going to use a distributional approximation. It's not going to use randomization. And we're going to use that F distribution to approximate the null distribution. So in order to use that approximation, we need these two conditions to be met. One is that the data needs to be normally distributed, or all of the sample sizes in each of the groups have to be greater than 30. And the other condition is that the variances of each group need to be about equal. And the way that we check that is we take the maximum standard deviation divided by the minimum standard deviation. We want that to be less than 2. So again, I'd like you to think about how you could check those conditions using some summary statistics that you've learned before. Pause the video and then come back when you think you have it. All right. So for the first one, I think that the tally command is going to be the one that works for me. And I'm just going to tally one thing. So I'm going to do a tilde, and I'm going to tally marital underscore status, comma, data equal GSS. And this will tell me how many people there are in each category. So it looks like the smallest group is 75 people. And 75 is greater than 30. So the first condition is met. And then the other one is about the standard deviations. So I'm going to do the SD command for standard deviation, parentheses, and then I want to do the standard deviation of number of hours worked last week, tilde, marital status, because I'd like it to be broken down into those groups, and then data is equal to GSS. If I control enter here, now it's giving me all of these different standard deviations. And so then I need to do a little bit more work. I need to find the maximum, which looks like 16.68, and divide it by the minimum, which looks like 13.72. And the ratio of the largest standard deviation to the smallest is 1.21, which is less than 2. So the second condition is met. So we're okay to use that F distribution as our distributional approximation.